In this video, we are going to understand the difference between ohmic and non-ohmic resistor and how to identify them from IV graph. So let us begin with an ohmic resistor. Ohmic resistor, as the name suggests, is the one that obeys Ohm's law. Ohm's law says that current flowing through any 2 points between a conductor is directly proportional to the potential difference between those 2 points. So if a resistor is ohmic, it must obey Ohm's law such that current flowing through the resistor must be directly proportional to the potential difference across it. This means that if I plot a graph of I versus V, this graph must be a straight line that passes through origin. If any resistor or any conductor has this relationship, this kind of IV graph, we say that that resistor obeys Ohm's law. So for an ohmic resistor, the graph of current versus potential difference must be a straight line that passes through origin. So most metallic conductors, they obey Ohm's law, and the relationship between current and potential difference for these conductor is linear. That means when you plot their graph, you should get a straight line that passes through origin. Non-ohmic resistors, on the other hand, are the ones that do not obey Ohm's law. So when they do not obey Ohm's law means the relationship between current and potential difference here is not linear. That means current will not be directly proportional to the potential difference. So for non-ohmic resistor, when we plot a graph of I versus V, it has to be non-linear. So it could be a curve, which is a quadratic function, or it could be an exponential function. The main idea is current is not directly proportional to potential difference, so the graph will not be a straight line passing through origin. So any such graph represents non-ohmic resistors, and we can say that current versus potential difference graph is not a straight line. Examples of non-ohmic resistor could be transistors, diode, or many of the components that we use in modern devices. Now let's take an example to solve a problem. In this question, we have performed an experiment, and from the experiment, we are going to identify whether the resistor is ohmic or non-ohmic. So here you have a resistor connected to an electric circuit. The potential difference between the two ends of resistor was changed, and the current passing through it were obtained, as in the following table. Graphically represent the relationship between potential difference and electric current. So in the first part of the question, we need to plot a graph of this table. Now the question says potential difference between the two ends of the resistor was changed. So this was the quantity that was changed. That means we are controlling this quantity. And any quantity that you change in an experiment is treated as the independent variable. An independent variable, we always plot it on the x-axis. After changing the potential difference, these were the current values that were obtained. We measured these values of current. So any quantity that you measure is the dependent variable. And dependent variable, we usually put it on the y-axis. So when you plot a graph of I versus V from the readings given in the table, you get a graph like this. Now what is important while plotting this graph is that you must label the axis properly. So if my x-axis is potential difference, I will write the name potential difference with the correct unit. Y-axis is current, so I write the name current again with the correct unit. Then when you put the points on the axis, when you put numbers on the axis, you have to ensure that the intervals are equispaced. That means the difference between any two consecutive points on the graph must be the same. So if I take difference between 0 and 2, it's 2. Between 2 and 4, again 2. Between 4 and 6, again 2. Do not directly take values from the graph and put it on the table. You have to make sure that the values are equispaced. Now, how do you decide what interval to choose? Always look at the range of your graph. So my potential difference values here are going from 0 to 16. So I know if I have to put 16 number on x-axis, it will get difficult. So if I want to put numbers from 0 to 16, I can take my interval to be 2. So we can go from 0 to 4, 6, 8, and so on. You can also take your interval to be 4. So you can go from 0, 4, 8, 12, and so on. So the choice of interval is entirely yours depending on what kind of graph is given, but you have to ensure that they are equispaced. You do the same thing along y-axis. Along y-axis, I have the values of current. So the interval over here is 0.5. That means the difference between each consecutive term will be 0.5 ampere. And then you plot the points. After we plot the points, we draw the line of best fit. The line of best fit is the line that passes closer to majority of the point. For now in my graph over here, it passes through all of them because it is a linear graph. And even if there was an outlier, even if one of the points were like outside of this line, it's okay. But you have to make sure that it passes close to majority of the points. So this is how we plot the graph of the reading given to us. Next in the question they are asking you, is the wire ohmic resistor? Explain your answer. Now ohmic resistors are the ones that obey Ohm's law. And Ohm's law says that current is directly proportional to potential difference. That means the graph of I versus V must be a straight line passing through origin, or the relationship between them must be linear. And since we got a linear relationship between current and potential difference, and the graph is a straight line passing through origin, we can say that the resistor here is ohmic resistor as it obeys Ohm's law. Then in part C of the question, we need to calculate resistance of the resistor from the graph. Now we know resistance R is defined as V over I. And from the graph, you can calculate the resistance by using the slope. So if I were to find slope of this graph, which is change in Y value over change in X value, for our graph, the y-axis represents current. So change in y value means we are going to measure the change in current, whereas x value is potential difference, so V, which I can write to be equal to 1 over R. So I can find resistance from the graph by taking reciprocal of the slope. So let us first find the slope of the graph. To find the slope, we will take any 2 points on the graph. So let me choose those 2 points to be here at 0, 0. So this will be my x1, y1. And the other point I will take here at 8, comma 1. This will be my x2, y2. Now let's calculate the slope. So slope will be equal to y2 minus y1 over x2 minus x1. So y2 over here is 1, y1 is 0, x2 is 8, and x1 is also 0. That gives me the slope to be 1 over 8. And I can find resistance to be equal to reciprocal of slope, which is 8 ohms. Now, if you have an IV graph, that means I on the y-axis, potential difference on the x-axis. In that situation, you can calculate resistance as 1 over slope. But if it was opposite, if they give you a graph where potential difference is on the y-axis and current is on the x-axis, in this situation, resistance will be equal to slope. So while finding the resistance from the graph, always pay attention to the axis. Because once you change the axis, the way we determine resistance will change. I versus V, you have to take 1 over slope. V versus I, you have to just take the slope to find resistance. Now let's discuss another similar question where a student performs an experiment where she can change the potential difference. Again, if she is changing the potential difference, that means this becomes the independent variable. And if it is independent variable, you have to plot this on the x-axis across a resistor and measures the current. Whichever quantity you measure is dependent variable, and dependent variable always goes on the y-axis. The table below shows her reading. In the first part of the question, we have to graph the reading. So once you identify your independent and dependent variable, now we can plot them. While we are plotting, we have to ensure that the intervals are equal. And how do we determine the interval? First, look at the range of your readings. So here my battery voltage is going from 0.2 to 5.8. So I can take potential difference values going from 0 to 6. And once I know the range, I can decide my interval. So 0 to 6 is not a big range. I can fit them all in a graph. So I can take my interval to be 1. That means on the axis, I can put the values of potential difference going from 0, 1, 2, and until 6 like this. We do the same thing for current. Current is going from 0.05 to 0.25 ampere. So we can directly take the interval to be 0.05. And when you plot the graph, you get something like this. So notice how all of the consecutive values on the axis have the same interval, they have the same difference, and they are equispaced. So do not directly put the numbers on the table on your graph. You have to make sure that these points on the axis are equispaced. They have the same interval. After you plot the points, you will have to draw the line of best fit. Again, line of best fit must be a smooth line passing closer to all the points. It's not necessary to include everything, but it must pass through majority of the point. Next part of the question is asking us to identify if this is ohmic or non-ohmic. Now, like we discussed before, for any ohmic resistor, the IV graph must be a straight line passing through origin. Here, this graph is non-linear. And if it is non-linear, that means the resistor is non-ohmic. That means current is not directly proportional to potential difference. In the next part, we need to calculate resistance if it is ohmic. So since it is not ohmic, we don't have to calculate the resistance. In case the resistor is non-ohmic, explain how would you determine resistance if it was ohmic. How would I find resistance of this resistor if it was ohmic? So we follow the same step like the previous problem. This is an IV graph. Slope of the IV graph is 1 over resistance. So if I want to find resistance, I will take 1 over the slope. So we will first find slope of the graph, then take reciprocal of that slope to find the resistance R. So this is how you can determine whether a resistor is ohmic or non-ohmic by looking at their IV graphs.